So today we're going to cover Chapter 11, Lesson 1. I'm going to actually teach this in 2 days. So I'm not going to go over the properties or the rules. I'm just going to talk about what a sequence is and what a series is. And then tonight when you're doing the homework, you're going to be plugging in values for the variable to make a sequence. And then once you get the numbers in the sequence, you have to add them up. So it's going to be pretty simple basic math. So let's look and see first what a sequence is. A sequence is a function that computes an ordered list. Now, your sequence can be finite, meaning it ends, or it could be infinite. And notice it's got this ... indicating that it's going to go forever. Yes?
Why is it pronounced finite if you put an IN and it's infinite?
I don't know.
Why is it Nevada? Wait, what was it?
I don't know. All right, so an infinite series is, again, a series that goes forever. This series, or this sequence right here, is the sequence of even numbers. Now, we're going to be seeing a lot of different notation and abbreviations for things. Now, when we talk about like the position or the spot that the number is in your sequence, for example, this number 2 that's right here. This is in the very first spot of our sequence. So we're going to see some notation, and this is called A sub 1. And that little 1 is just indicating it's the first number in your sequence. Then the 4, this would be A sub 2. And then the 6, A sub 3, and so on. So this is just some notation to help you identify numbers in the series, in the sequence. So there is a function rule that we can use to calculate, say, the 100th term in this sequence of even numbers. And the rule to calculate a number that's really far into the pattern for this even numbers, and the rules change depending on the sequence, but the rule for even numbers is A sub n is equal to 2 times n, where n is going to represent the number of term we're looking for. So for example, if I wanted to figure out what is the 5th term in my sequence of even numbers, I would do A sub n, and this is my label saying the 5th term, and then again I would take the n out and put the 5. So the 5th term in my sequence of even numbers is the number 10. And if you notice here, 1, 2, 3, 4, 5, my 5th number here in the sequence is the number 10. Now, let's say I wanted to find the 100th term in my sequence of even numbers. I would do A sub 100 and then do 2 times 100. So the 100th term in my sequence of even numbers would be the number 200. Now, we're going to learn later on how to write these rules, but for now, in tonight's homework, I am going to give you the rules, and I'm going to tell you how many numbers to find out. So here's my first example. It wants me to find the first 5 terms of the sequence using this rule. So what I need to do here is I'm going to figure out what A sub 1 is, so my first term. So every place that I see the letter N, I'm going to put a 1. So 1 plus 1, 1 plus 2. So the first term using this rule in my sequence is going to be the number 2/3. So that is my first term. Then to find A sub 2, or my second term, I'm going to replace all the n's with a 2. 2 plus 1 over 2 plus 2, and I get 3 over 4, and that's my second term. Now we'll start to see a pattern here. Notice that my numerator is increasing by 1, and so is my denominator. So here, A sub 3. Now notice it said to find the first 5 terms. So I have to do this until I get A sub 5, because I want the first 5 numbers. So I'm going to do 3 plus 1 over 3 plus 2. And I get 4 over 5. That would be my third term. For the fourth term, 4 plus 1 over 4 plus 2 gives me 5 over 6, which is my fourth term. And then lastly, the fifth term, I would do 5 plus 1 over 5 plus 2 and get 6 over 7. So this is how you can figure out the however many terms they tell you. You just keep repeating by plugging in however many terms they look for. Let's try another example. Again, I want the first 5. I'm giving you the rule. So we're going to, every place that we see the letter N, I'm going to replace it. And I'm going to increase it by 1 each time. So the first term, a sub 1, will be negative 1 to the first over 2 to the first. I get negative 1 over 2. So my first term in the sequence is negative 1/2. Next, to get the next term, I plug in 2. Negative 1 to the second, 2 to the second. Negative 1 squared is positive 1 over 2 squared, which is 4. So my second term is 1/4. For the third term, we plug in a 3. Negative 1 to the third, 2 to the third, negative 1 over 8. So my third term is negative 1/8. Now, this is an example of an alternating sequence. Notice the terms in my sequence, or the numbers in my sequence, are alternating signs. The first term was negative, then positive, then negative, and now the next term I'm going to find, or the next number in the sequence, will be positive. Negative 1 to the fourth over 2 to the fourth gives me 1 over 16. So my fourth term is 1/16. And lastly, it said 5 terms. So I'm going to do it one more time. Plug in a 5. Negative 1 to the fifth over 2 to the fifth. Negative 1 over 32. So the fifth term is negative 1 over 32. Notice that whenever you are raising a negative number to an exponent, if the exponent is even, you get a positive answer. If it's an odd number, you get a negative. So this is how we're going to do it. I'm going to give you the rule. I'm going to tell you what to plug in. Find however many numbers in the sequence they tell you to find. Then once you get these answers, you're going to add them all up. And we need to find some vocab here. The first vocabulary word we have here is convergent. And what this word means is that our sequence is going to get closer and closer to some real number. So for example, let's say my function rule was 1 over n. And I said find the first 5 terms. So notice when I plug in 1 over 1, I get 1. And then the second term would be 1/2. Then 1/3, 1/4. Notice how it's converging slower and slower to 0. It's getting smaller and smaller. But when a series or a sequence is divergent, that means that it doesn't converge and it's going to keep growing and growing until it gets to infinity. Now, the examples I just did were to complete the sequence. A series, on the other hand, is going to be the sum of the sequence. And this is what you're doing tonight for homework. You are going to sum. So I'm going to be introducing some notation. This symbol right here, this sigma, is representing, it's a symbol that represents to sum up. You can have a finite sequence and again, an infinite sequence. So, and show you the properties and the rules today. I'm going to show you 2 examples of how to do your homework tonight. So I'm not going to go on, and this is what we're doing in the homework, and this is some notation. So let me show you what it means. So right here, the bottom number is your summation index. Now this letter I is not the imaginary I that we're used to. This I is just a variable. it's like X. Now, they usually use I, or they might use J or K. It really doesn't matter. It's a variable, so it's just like X. So what we're going to do is we're going to start by plugging in 1, and then we're going to keep going until we get to this top number. So I'm going to plug in 1, 2, 3, 4, 5, and 6, and substitute it in for I, and then follow order of operations and get my numbers. So let's try it. I'm sorry? Where is that? Okay, I wrote that in there, so just write it in your notes. This is a problem from the homework, so I just wanted to show you how to do it. So let me go ahead and show you what's expected for your homework tonight. All right, so for your homework tonight, so again, this is the summation notation. This is the function rule that we're going to plug in our values of I. So basically what I'm doing here is I'm going to plug in I equals 1, I equals 2, 3, 4, 5, and I stop at the top. Okay, so I'm going to plug all those in and get all those answers. So A sub 1, that's my first term. I'm going to do 3 times 1 minus 2. 3 times 1 is 3, minus 2 is 1. So my first term in my sequence is 1. Now I'm going to plug in 2. 3 times 2 minus 2 gives me 6 minus 2, which is 4. So my second term is 4. Then I'm going to plug in 3. 3 times 3 minus 2 gives me 9 minus 2, which is 7. So my third term is 7. Then I'm going to plug in 4. And I'm going to keep going until I get this top number. So I have to go all the way and find A sub 6. So 3 times 4 minus 2, 12 minus 2 is 10. 3 times 5 minus 2, 15 minus 2 is 13. 3 times 6 minus 2, 18 minus 2 is 16. I'm now going to take these numbers and I'm going to add them. So when it says define this series, what you're doing is adding up all of the numbers in the sequence. So I'm adding 1 plus 4 plus 7 plus 10 plus 13 plus 16. Doesn't matter the order you add them. Once I add all of these, I like to make like groups of 10, but you can do it however you want. If you want to work left to right, 1 plus 4 is 5, plus 7, 12, plus 10, 22, 22 plus 13, 35, plus 16 is 51. So the answer to this problem is 51. I'm going to show you one other example where we don't start at 1, and this is number 35. I thought, here we go, 36. So again, this is just a homework problem, but you're doing odds for homework. So what we're going to do here is you're going to start now not at 1, but at 3. So you're going to do A sub 3. And then you're going to, where you see the letter I, we're going to put a 3. Notice the number up at the top is 7. So I stop at 7. So A4, 5, 6, and 7. And I'm going to get all my answers. Yes. All right, so again, the I at the bottom, this is the number that you start with when you're plugging it in. So I'm starting to find the third term, this time not the first. And then I want to go all the way to the 7th term. So 15 plus 2, I get 17. And then 5 times 4 plus 2, 20 plus 2, and I get 22. 5 times 5 plus 2, 25 plus 2, so I get 27. 5 times 6 plus 2, I get 30 plus 2. And then 5 times 7 plus 2, 35 plus 2, and I get 37. I now need to add up all of these numbers. Once I add them, I get 135. So that's my answer. So you're just using the rule that is given. You start at the bottom number and go to the top number. Homework, so again, number is probably going to be like 100, and you won't be able to do it by hand. You have a quiz, sorry. On your last quiz, you're going to get a really huge number that you'll have to, find the sequence of. I know there's more in the notes. This is what I'm going to cover tomorrow. These are shortcuts that we can use instead of having to figure out all of these one by one. Because on the test, the series of. So your homework tonight is just following order of operations and plugging it in and getting the sum. So this is the homework problems. The 11-1B homework, that's where we're going to use the rules and the properties. Good, that's it.